to get started, first things first is our order form needs to be filled out correctly. I am using Exocad's demo case so that if you guys have the software, you can actually follow along, or perhaps use a recording of this session so you guys can practice back in your lab or clinic. So first things first is filling out the order form. We want to select the teeth that we're going to be replacing with the partial denture with the restoration type partial denture. Also, for this particular workflow, you want to use the 3-piece Quicksnap workflow, which will create the mesh for the metal framework, and then also the gingiva and the spacer underneath the metal. And so that's what we're going to be designing today. All right, once that's all selected, we'll jump into the design. That's where I'm at right now, and we are going to move forward with the design process. So the software is going to want us to do a model block out, where you just select a good insertion direction, and then we tell the software next. The module that is necessary is the partial denture module to be able to do this, and the denture module. You need both. All right, so now that we're here, we're going to do a quick setup. We are going to just place the teeth in place. Once they're placed, you can actually flip through the different libraries to see if there's any that you like better than another, and then click next. And then we'll do the quick setup for the other side of the arch. Now, in this particular step, I try to tell people to try to compartmentalize your design process, so each step is specific for what it's meant to do. So here we're just choosing the libraries. We're not trying to get the positioning correct or the size of the crowns correct. That's not addressable at this point. Once we have the library selected, we can go to the next step. And here's where you can start getting a bit more picky about the orientation of your crowns. Depending on the number of teeth that I'm working on, I like to do the majority of my positioning in the advanced tab. It just gives me more control in the way that things scale directionally. And so that's why I try to do most of my work here. So I'm going to try to get these more or less in the ideal position.
And are there restrictions on the library that they can use? Are they stuck with denture teeth, or are they?
No, they're not stuck with denture teeth. So, in fact, you get to use, let's call it Exocad's regular crown and bridge libraries. Okay, so we will get the position of the crowns more or less where we would want them, ideally speaking. And then the other reason why I like to use this tab is I get to use this tool here. This slider control allows me to, say, age the teeth according to what the case looks like, so that my custives aren't too pointy in comparison to the existing dentition. Okay, so let's say for now I'm happy with the setup. I'm going to go next, and the software is going to want me to do some free-forming changes. I usually tell people, if you find yourself digging in anatomy because you don't like the amount of detail that the library gives you, you should just go and choose a different library. You should not be spending a lot of time digging in anatomy for a couple of reasons. Number one, I think, is a waste of time. And number two, if you decide to get way too detailed in your design, you may be limiting your manufacturing process to not get the same level of detail. So I just try to get most of that work done for you through the library that you select. Okay, so after that, we'll click next. Software is asking for contacts. We don't want to do any contact adaptation. The software will actually do that for us in the subsequent steps when we get to designing the actual partial. And so now the software wants us to draw the outline of, let's call it in the dental CAD, it will be the virtual gingiva. Okay, this for us is going to be the area where we are going to have that mesh on the partial. So you want to draw that as big or as small as you need it to be. Okay, just make sure that you give yourself some extra room. It's preferable for it to be too big than for it to be too small. For optimal results, I say you should do no less than 2.5 millimeters of thickness here for that base. If you can go up to 3, then please do that. Your results will be even better. And then we'll do the same thing on this other side. So we'll go ahead and draw our mesh and change the thickness again to 3 millimeters. Okay, and we can move forward. There should be very little changes that need to be made here. Perhaps we just want to pull, let's call it the papilla down here to close that up. On the other side, we're probably not going to have that problem. We can reduce some of this gingiva here, and then we can move forward. The software is now asking for connectors. Now, here's where it can get a little bit tricky depending on the results that you're looking for. If you create a connector, eventually the software is going to link all the teeth together, right? And so you'll end up with, say, a bridge. Now, if you are planning on creating different shades for each individual tooth, then you want to get rid of those connectors. Okay, so if you know that all your, say, all the teeth on the right side are going to be the same shade, put your connector on, and then your final output will be those two teeth together. And in the nesting software for the printing, you'll be able to select them all with the same shade. For the second demo, this time around, we are going to do, we're going to connect them all, okay? And I am a strong proponent that the only connector shade that you should ever use is this plus sign. I think it's the best one, and we can get into that some other time. But that's pretty much all the design process. So once you're done, the software will give you the option here to move on to the partial CAD. Okay, so that's what we're going to be selecting, and click next, and then the software is going to launch the partial framework, or the partial CAD, as it's called. All right, so here, as you can see, it's a different software. It is called the partial CAD. This works completely different. It's been Exocaded in a way so that it looks more familiar. So it has the workflow at the bottom. All the steps and all the parameters are to be controlled down there. This first step, I'll kind of talk you through it. The first step is just to do the model block out once again. Now this time is for the partial CAD. We are going to leave it the way it is. If you wanted to change it, you can rotate your model and establish a new insertion direction, and then click Set from View. So now that is going to be your insertion direction. Okay, and then once you have it, you can click Next, and the software will go through the process of creating or adding the blockout wax to the model. And at that point, we'll be able to use different tools to modify that the blockout wax. So I'm going to remove a little bit so I can expose the retention areas for my clasps. Also like to add a little bit of extra wax here so that the transition from tooth to the tissue will be a little bit smoother. And then we'll go to the next step. And now the software is going to ask us to draw the outline of the mesh. So we're going to follow this as closely as possible. And then we're going to do the same thing for the major connector. However, for this workflow to work best, when you do the major connector, you want to overlap, or you want that major connector to go over this outline that we're creating right now. And I'll explain what I mean by that here in just 1 second. Oh, come on. Don't do that. There we go. Okay, so when you go to draw this here, and I'll just do something quickly. You want to overlap the two lines, something like this, okay? And then we'll just create the base here. Once again, we'll cross these over, and then we'll bring this back up here. There we go. Okay, so then we'll go next. The software will identify the two or the three, and then show us what each one is going to be looking like. Now we have all the parameters here to control everything that we're going to be creating. So the space underneath the mesh or the metal framework, we get to determine how thick we want that to be, which is going to be one of the pieces that's going to be manufactured. We get to pick how thick we want the actual metal part to be, and then also how thick we want the top part. So all of that we can control here in the parameters, whether it's going to be the split gingiva and the thicknesses there, or the mesh and the thicknesses, and also the details for the major connector. You can get as creative as you want. There's also one parameter that is new to the software that I find really helpful, just because it makes things look a lot cleaner at the end, and it's this mesh rim. So rather than having your mesh open like this, where the metal just ends there and you just have a hole, the software is actually going to outline the entire mesh in metal so that it looks a lot cleaner. Okay, so I'm just going to add that there so we can see the results. And so we'll go ahead and click next, and then the software will turn all of this into, let's call it a workable wax within the software. So you get to choose from the mesh pattern from a menu, and the software has, let's call it some, let's call them basics. So you have circle and you have square, but then you can also add a picture of the type of mesh that you would like. And that is installed somewhere in your software. You can ask your reseller about it. And then what the software will do is that it'll turn it into a tile. And so it'll repeat the same image over and over. You'll be able to play with the sizes of it. So for example, just to take it to the extreme, I've seen a framework designed with SpongeBob SquarePants. Somebody loaded a picture of it, and then the holes for the mesh were just a bunch of SpongeBob. So once we get here, we get to draw the clasps and the curves. So for example, we are going to start our line here and wrap around the entire tooth, and we can end it wherever we want. There are different types of clasps that you can draw depending on the number of lines that are required. So if you wanted like an approach arm, I know that it wouldn't apply for this workflow, but just to let you know that it is possible within the software. You can draw clasps, and then depending on the number of lines that are required for you to create that particular clasp, we can tell the software to consider that when calculating the mesh for it. So here we'll just kind of keep it simple, and then we go to the next step, and now the software is going to allow us to select the type of clasp that we designed. So here is just a single curve making up the entire clasp. All we have to do is click on those lines, and it'll give us a preview of what the clasp looks like. And we can grab these points and move them around to create the shape that we want, etc., etc. If you get here into the settings, that you can play around with how thin the ends are, what kind of fading from the thicker part down to the thin edge, all those things you can control here. Again, for the sake of demo, I'll just keep it simple and keep all the default values. So I'm going to click apply, and it'll turn that clasp into wax, and then we'll go around and do the same thing with all the clasp lines. So okay, that's pretty much it for that. Then we'll go to the next step, and now we get to use this tool that I find really, really cool. It's called the clone wax tool that allows us to add material or wax at a set thickness. Doesn't matter how many times I go over the same area, it won't violate the thickness that I set. So, for example, here for occlusal rests, we can select that, and we can change the size of our cursor to be the size of that rest. And then with a single click, the software will add a thickness of 0.6 millimeters of wax. And it doesn't matter how many times I click on this, and I'm clicking and holding and clicking, it'll only add 0.6 millimeters of thickness. And so we'll go ahead and add the rest here for all of our units, and then we can change to a minor connector so that we can connect our clasp to our mesh. And so once again, that is a thickness of 1.2 millimeters, and doesn't matter how many times I go over, so I'll just go back and forth here all I want, and it's only going to add 1.2 millimeters of thickness where I'm clicking. All right, and then once that's done, we can click next, and now we get to draw finish lines. For the sake of demo, I'm not going to do that right now, so we'll just go to the next step, and now the software will allow us to freeform or make changes to the wax. So, for example, I can select here to smooth, and then I can smooth out that transition area between my major connector and the mesh, just to make it a smoother transition. So here, where things end up looking kind of rough, I can come in and smooth it all out, so it looks a little bit better. And then also, this software has something that I really like. I can actually hide everything else in the case, and I can flip my design upside down and address any imperfections on the underside of the structure. And so I can smooth things out from from underneath, like here, to make transition points a little bit smoother, so that they won't feel as sharp or rough in the patient's mouth. Okay, so we'll do something like that, and then we can click next. And the software will now ask us to assemble parts. Now here we can play around with all the parameters that would change the fit of these parts one within the other. Okay, we'll just leave it as defaults, which is just to go on that for just a second. Whenever you get into anything new for you in CAD, always use the software's default values. Don't go asking your buddy what values or what parameters he uses, because your manufacturing process may be different than what his is. So the capability of accuracy may be better for him than for you, or vice versa. And so the parameters are not going to be the same. And so you have to adjust to what your manufacturing process can provide for you. We can actually tell the software to apply the build, so it finalizes everything. And then it will give us the option to do what's called an exploded view, waiting for it to calculate the exploded view. So while it's calculating, just as a heads up, anybody's going to get into this, you want to make sure that your computer is actually really good, because the requirements for this particular software are actually much higher than regular Exocad.